Hello, everyone. This is Jerry from Panasonic. Today, on behalf of Virtualization Expert Group, I would like to introduce about VirtEG's activities. Our EG is interested in virtualization solutions for AGL and now focusing on support VirtIO for AGL. Oops. Okay. As the year of change is coming to the automotive industry, that the cockpit is transforming towards fully digitalized. With reduced cost and space, ECU consolidation has been one of the main directions of the automotive world. So here, the hypervisor solution, which can enable different function safety level domains be placed on a single ECU, has been a popular solution. However, there were serious pain points around virtualization in automotive in the past. Parallel virtual device driver layer and even part of the application platform layer, such as AGL, is depending on both hypervisor and SOC. So this is because most of current virtualization solutions have a fragmented parallel virtual device implementation and thus have incompatible parallel virtual device interface for the upper layer software. So fortunately, this pain can be relieved by utilizing VirtIO as a common device framework. So VirtIO is an open source implementation of parallel virtual device and has been utilized extensively in the cloud servers in a region. By introducing VirtIO, there will be a common interface and implementation for parallel virtualization devices, which can establish an efficient ecosystem for AGL virtualization with healthier competition. As I mentioned, VirtIO has been widely used in cloud servers. However, automotive systems need various additional peripheral devices as shown on the right-hand side, including GPU, video, audio, sensor, CAN, and so on, which need collaborative work. And that is one of the goal of our expert group. So even though more work is needed to extend VirtIO, together with the AGL reference hardware proposed by the AGL reference hardware EG, so VirtIO work can help to establish AGL virtualization environment where various hypervisors, SOCs, and peripherals are available for OEM and Tier 1 to choose, which also marks that AGL has been virtualization ready for the future products. Aligning with this concept, our VirtEG started to introduce VirtIO into AGL, and I'm glad to announce that VirtIO was officially supported from the last AGL main version, Kokikoi. Now, let me introduce VirtEG's work in 2020. In the previous year, our EG's work has been created basic infrastructure so that AGL can be easily used as a front-end guest VM with the help of VirtIO. Basic devices needed for IVI or IC profile, such as block device, GPU, input device, network, and so on, has been supported. In order to prove our concept, our EG also attended Automotive Linux Summit last year to present the EG work for VirtIO. Two EG members, Linaro and OpenSynergy, showed their talks with VirtIO, which further proved that hypervisors and SOCs interchangeability brought by VirtIO. Now, let me show part of demo video from the ALS. For the full version video, please check VirtEG's conference page. So let's go first with Linaro's demo.
Let's talk about the demo. The aim of this demo is to show a single software stack running on multiple hypervisors and also on multiple pieces of hardware. So let's talk about the KVM deployment first. So here's what KVM looks like running with virtualization. So you have firmware boots in to the host Linux kernel. Because of the way KVM is designed, it's sort of all one blob, but what's actually happening on ARM is we've got the host kernel mostly sits in EL1, but then we have a little trampoline that runs in EL2, which is the hypervisor layer. And then for user space, we've got QEMU, and then on the guest side, it's the AGL user space. So the demo platform that I'm doing the KVM demo on is a Marvel Macchiato bin. So it's basically a ARM development board. It's got 4 A72 cores, 62 gigabytes of RAM, and an NVIDIA GK208 running the Nouveau driver stack. And this is on top of a Debian Buster OS. So let me just switch across to my camera. So there you go, it's an ARM64 machine. If I maybe LSPCI, and then you can see hardware. So I think we'll get QEMU up and running on this. This is the sort of pseudo air conditioning system, and we can turn things on and off, enable seat warmers. There's obviously no real hardware that we're attached to. So now let's talk about Zen deployment. So the Zen system is looks broadly the same at the top end, so it's the same AGL kernel, the same AGL user space, but this time we've got the Zen hypervisor. The design of Zen is the hypervisor is much thinner. Usually it leaves the hardware emulation to something else. So in this case, in a DOM0 deployment, the guest has direct access to the hardware, and the hardware is fully emulated mVirt board, and I'm doing this with QEMU's ARM64 emulation. So as far as the Zen hypervisor is concerned, all this hardware really exists. That's perfectly fine for VirtIO. In fact, having real hardware for VirtIO is one of the things you can do. Right, let me just, there we go, talk about the host platform. So it's a Core i7 x86 64 machine. I'm emulating the ARM64, so it will run a little bit slower. Got 32 gig of RAM in this machine, and I've got Intel graphics instead of NVIDIA. So let's just switch across to the demo. There we go. So just bring it up. So there you go. You can see that's the Zen hypervisor as it detects the hardware and loads the guest kernel into position. And there you go. And there you go. You can see it all pops out. And then we'll just click the same buttons as before. Takes a little bit longer for the actual software to run, but as you can see, the graphics respond pretty quickly. There you go.
Now, let's watch the demo video from OpenSynergy.
Hello, today I'm here to tell you about OpenSynergy setup with 2 automotive-grade Linuxes running on top of the Cocos hypervisor, running on top of the automotive-grade Linux reference platform for the Renesas RCAR H3 SoC. Looking at the architecture of the setup, you can see the AGL meter or instrument cluster guest on the left. On the right, you can see the AGL IVI guest. The AGL meter guest on the left serves up physical devices to the AGL IVI guest using VirtIO. VirtIO offers a very big advantage in that we can easily upgrade the AGL IVI guest because it is independent of actual physical devices. In this setup, the AGL meter guest is running AGL HH or Happy Halibut, whereas the IVI guest is running AGL Jumping Jellyfish. Because of VirtIO, it only took OpenSynergy about 2 weeks to port the Jumping Jellyfish version to the setup. Not only are we using the hypervisor so that both of these AGLs can run on top of a single SoC, we also are using VirtIO technology so that both of these AGLs can share many of the devices provided by the platform. For example, VirtIO block to share the block device, VirtIO RNG for the random number generator, input for touch, 2D GPU to share the display controller as well as net so that the 2 guests can communicate by IP. Let's have a look at the HVAC settings so you can see that input and display are working. You could say we can touch, and you see the display works fairly well. For the 3D acceleration, we are using the hardware-assisted virtualization provided by Renesys. In a future version, we plan to move also to VirtIO 3D GPU, which would allow us to be totally independent on the IVI side of the vendor BSP. Let's have a look at the navigation. So the navigation is using VirtIO network to access the internet. So the actual Ethernet device provided by the platform is owned by the instrument cluster automotive grade Linux. The IVI automotive grade Linux is getting to the internet via VirtIO network, so by accessing first the instrument cluster Linux, which then routes the request to the Ethernet interface and out into the internet. Let's have a look at the version that's running here on the IVI AGL, and you can see, in fact, it is the newest version, 10 Jumping Jellyfish. Thank you for joining me today for the description of our AGL cockpit controller demonstrator on the AGL reference platform.
So this is the end of the two demos from our EGS members in the previous year's ALS, and I'm also glad to announce that one of the member company, Open Synergy, is offering their demo as a VirtIO reference platform to the AGL members. So in this update, they have already included the VirtIO GPU 3D mode so that a fully virtualized GPU is available on the platform. So for details, please check the Open Synergy's webpage below. Last, I would like to give a brief introduction for the VirtEG's 2021 work. After VirtIO was successfully introduced last year, our goal this year is to make VirtIO in AGL to support more ICE, IVI, and even DMS and ADAS use case, which can help virtual AGL better fit the future product needs. Feature extension of VirtIO input, new supports of sound, SCMI, video encoder, and camera are on the plan of VirtEGs. So we believe with the virtualization EEG's work on VirtIO, virtual AGL will be more and more mature and will finally come to your car one day. Similarly to previous year, we will also have a presentation in this year's ALS showing talks from EEG members. So this year, we will also have a Google Summer of Code student working on porting VirtIO block to open source system supervisor Zhao. Our VirtEG session was awarded a most attended session in the previous year ALS, and you are welcome to visit our session this year. So this is the end of my sharing. Thanks everyone, and welcome to join our EG to discuss and contribute virtualization architecture to build a bright future for automotive together with us. Thank you.